This radar map visualizes an extreme logistical challenge, coordinating 48 teams across 104 matches, alongside the seamless movement of 20 million pounds of equipment. This physical mass must navigate the borders of 3 sovereign nations, each operating under distinct regulatory and customs frameworks, and it must happen under a strict zero-downtime mandate. Stadium changeovers and global broadcast streams cannot afford a single minute of delay. To handle massive demand surges, standard corporate supply chains usually rely on heavy capital expenditure. They build permanent infrastructure and lease vast horizontal warehouse spaces to stockpile inventory. FIFA abandoned that model. Instead of expanding physical footprints, they managed the tournament through an integrated framework called PPDS, harmonizing people, process, data, and system policies to substitute physical capacity with high-velocity data. By examining the underlying operations and AI architecture of this trinational machine, we can extract the precise mechanisms modern enterprises use to maintain resilience under extreme volatility. The total cost of ownership strategy for this tournament focuses entirely on existing infrastructure. 0 new stadiums were constructed from the ground up for 2026. This cross-section outlines the capital-light alternative, retrofitting venues with temporary modular systems. Engineers install vacuum ventilation and undersoil irrigation lines over the existing floor. Above that, a 2-foot sand profile acts as a root zone. Bermuda grass forms the surface, and machine-stitched synthetic fibers for extreme durability. Transporting biological assets like living sod, along with thousands of tons of licensed food and beverages across regions ranging from 70 degrees in Vancouver to 105 degrees in Dallas, requires maintaining an unbroken cold chain. Once inside metropolitan host cities, delivery fleets face severe municipal service level agreements. In major markets like New York, transport planners navigate rigid 9-hour delivery blackout windows and strictly enforced gridlock alert days. To prevent supply lines from collapsing under these barriers, logistics teams rely on real-time GPS telemetry to route trucks dynamically, scheduling off-peak drop-offs through localized micro-delivery hubs. Because local traffic ordinances artificially compress physical delivery windows, the broader cross-border staging networks must execute flawlessly to ensure inventory is positioned exactly when the blackout window lifts. Pushing massive freight volumes across the borders of Canada, Mexico, and the United States introduces the immediate risk of catastrophic customs bottlenecks. To legally bypass delays, the System Policies pillar of the PPDS Framework utilizes specialized customs documentation, specifically deploying USMCA-compliant ATA carnets and temporary import permits. This flowchart tracks the cross-border relay workflow. Cargo moves from global origin, clears via USMCA carnet, transitions into regional refrigerated fleets, bypasses blackout zones, and achieves zero-delay delivery. To eliminate tracking fragmentation, this entire relay is monitored by a centralized technology command center. Inside this command center, a highly integrated database aggregates disparate data streams. It pulls flight paths, live shipping manifests, digital ticket scans, and even localized crowd density sensors into a single operational dashboard. Machine learning algorithms process this telemetry, allowing logistics teams to automate complex route adjustments and model disruptions before they impact physical transit. By utilizing artificial intelligence to manage the data volume, a lean team of 600 operators can control the trinational footprint. Without automation, the same operational output would require 1,800 manual workers, heavily inflating operating expenses. The efficiency required for physical cargo also applies to the digital commercial product. For a multi-billion-dollar broadcast, global video feeds must achieve a latency of under 5 seconds. To meet this precise target, high-performance edge computing servers are deployed directly at the Dallas International Broadcast Center, synchronizing massive video streams in real time. Real-time synchronization extends directly to the athletes. Players are required to wear biometric tracking sensors that continuously feed cardiac stress and muscular load metrics to AI performance platforms. This flowchart outlines the semi-automated offside technology. First, every participating player undergoes a high-speed body scan, capturing accurate dimensional data. This generates distinct 3-dimensional player avatars. During matches, skeletal tracking algorithms utilize these models to map spatial movements, maintaining accuracy even when visually obstructed. When an offside decision is evaluated, this spatial data automatically translates into a realistic 3D replay. Viewers see precise physical representations of the actual athletes rather than generic estimates. That technological exactness also applies to officiating perspectives. AI stabilization software runs continuously on live first-person referee body cameras, eliminating up to 50% of visual jitter for the home audience. By deploying edge computing and artificial intelligence, raw biological and spatial data is instantly transformed into a highly transparent, immediately consumable commercial asset. As the tournament progresses, an influx of 6.5 million traveling fans puts extreme pressure on regional commercial corridors. This sudden spike in demand creates intense logistics volatility. Inbound refrigerated freight rates to key host cities surge up to 30% over spring averages. The traditional corporate response to localized demand surges is to lease additional physical warehouse square footage. This split-screen comparison shows Fifa's operational alternative. Instead of expanding outward, logistics operators bypass capital expenditure by driving maximum efficiency along the Z-axis. Facilities adapt their storage workflows by implementing automated satellite shuttles and high-density vertical spiral conveyors. These specific hardware installations reclaim up to 75% of wasted floor space and reduce manual product retrieval times by 40%. By maximizing automated vertical density, supply chains can absorb massive short-term commercial spikes without taking on permanent physical liabilities. The operational design of the 2026 World Cup demonstrates that raw physical capacity is no longer the primary metric for supply chain success. To handle volatile consumer markets, enterprises must abandon static inventory planning. Replenishment forecasting must be dynamic, bracket-driven, and linked directly to real-time telemetry. This ecosystem matrix illustrates the structural shift. Instead of isolated operations, suppliers, logistics partners, and customs agencies orbit a single connected database node. Expanding this digital footprint requires equal investment in operational defense. Interconnected logistics networks must proactively deploy AI-powered threat detection and automated identity verification to secure their supply lines. Global competitiveness is now determined by the velocity of information, the strength of public-private partnerships, and the integration of physical engineering with digital intelligence. The organizations that thrive under pressure will be the ones that halt reactive physical expansion and focus entirely on building agile, automated data ecosystems.